Hi everyone, my name is Feng Yi Chen. Today I will be walking you through how I designed the 3D casing for our personal panic button, Safe Alert, using TinkerCAD. So when I designed, I think that the casing needed to be compact, it needed to be safe to carry, and it had to be very easy for the user to open and close. So to start, I set my TinkerCAD snap grid to exactly 1mm so that all my measurements would be precise. And I bring a basic rectangular box and resize it to a very compact 50 x 80mm. So we can specifically choose this size so the device remain the small size and feel just like carrying a standard car key. Next, I apply a radius to the edge of the box. This is to give a rounded corners and act as a safety measure because we don't want any sharp edge that will harm the users or snagging inside their bag. Okay, so the next step is to design the internal structure. Because our device is battery powered, so the case must be easy to open so that user can easily change the battery when the battery run off. So instead of using any screw that can easily get lost, I redesigned a tool with free slip fit mechanism. So I created a frame which I saved as my own creation here with the measurement of 50 x 80 in the outside and the inner measurement is 45 x 75. So it will be leaving a 2.5mm wall thickness. So using this frame, I built a raised inner wall on the upper half of the casing and I engraved a matching groove into the bottom half. And this design allows the top and bottom cover to slide and lock tightly together so that it will very secure during daily carry, and anyone can effortlessly pull it apart to change the battery also. So for the upper half, I measured and cut out some holes for the slide switch, the 4 LED and the buzzer. While for the bottom half, I have left a space to put the PCB and make sure that the PCB can accurately fit into this space. So in the end, if we fit the upper part and the bottom part, this will become the final result. As we can see, the upper part and the bottom part can fit very perfectly and create this portable and useful panic button. In the final result, we added a keychain ring so that users can attach with their key or hang on their bag for use in any time and anywhere. Then I will continue explain the circuit simulation part of our project, which was done using TinkerCAD circuits. For the power supply, we selected a 3V button battery, but actually originally we tried to use a 1.5V AA battery, but during simulation showed it did not provide enough power to run all components. And also we considered a 9V battery, but the 9V battery is too large, and we think that it's not suitable for the portable panic button we want to produce. And next, we had to choose our primary input component, so we decided to use a slide switch instead of push button, because in a real panic situation, we think that a user might not have the physical strength or ability to hold a button down continuously. So with this slide switch, the user just can simply push it once and it will securely lock into the on position. So for our outputs, we needed both visual, which we use LED, and audio, which we use the buzzer. For the draw maximum attention in any emergency situation. So for the visual side, we use 2 red LED and 2 yellow LED. This specific color were chosen because they run very efficiently on lower voltage and can produce a bright and eye-catching warning in dark environment. So for the audio side, we integrate a buzzer. So the buzzer can generate a loud and continuous noise that will instantly alert people nearby. So finally, we carefully arrange the entire circuit in a parallel configuration. This parallel wiring is a crucial safety feature because it can prevent any short circuits and make sure that the power is distributed evenly. So because we arrange it in parallel, so even one single LED will accidentally fail, the buzzer and the remaining LED would still continue to operate perfectly. So when we running this simulation in TinkerCAD, we can prove that the LED, the 4 LED, the red LED and the yellow LED can successfully light up and the buzzer also can sound. This confirmed that we had a fully functional and reliable circuit ready for the physical build. That's all from me. Thank you.